recording. So this is the example number 3 from 3.15, the video I uploaded last night. I said that in today's session, we would go over it. Has anyone been able, I know I uploaded them a little bit late last night, but has anyone watched the 315? You can tell me.
I haven't.
Okay.
No.
Okay, so I think
I
that,
haven't either.
okay, so what we'll do is I'll wait and do this problem tomorrow. So that way you guys have time to watch the video, because I don't want to just dive into it and then you're like, I don't even know what the rest of the video is about, what the rest of the lesson is. But so we'll change that around. We're just gonna jump straight into some more practice problems. So this is actually, I'm not going to go back to the first practice exam. I'm going to move on to one of the newer ones. My reason for this is I was thinking about it the other day, and I was like, what if that first practice exam is so easy because that was the one that was available at the start of the year. So maybe they were just like, here's a really easy practice test for you guys to try out as more of like a diagnostic test, maybe. My concern is that maybe that's why it's so easy. So practice exams number 2 and 3 were uploaded very, very recently, within the past month or so. So I want to try going through these problems, and hopefully they'll be just as easy, and there won't be any issues, but we'll see. So once again, section 1, part A. So here you see it in an hour, 20 minutes for 28 questions, no calculator. Everything, the domain is the set of all real numbers, and angle measures are to be in radians. So those are the two main things. Remember that on this exam, you can write all your work out on this practice exam booklet, but only the answers in the bubble sheet are scored. So make sure that you are copying your answers into that. All right, so the first question, consider the function g and h given by g of x equals 4 to the x and h of x equals 16x plus 2. In the xy plane, what is the x coordinate of the point of intersection of the graphs of g of and h? So they're basically saying, when does 4 to the x equal 16x plus 2? So what do I have to do first?
Divide?
No.
I lied.
Do you have to bring the exponents down
I have to bring the exponents down, but how do I do that?
with log?
Not with the log. There's a special little rule, right, that we've gone over, that when the values have the same base, I don't know, 5 plus x. When the values have the same base, I can just say 3x equals 5 plus x. Right? Do we remember this rule?
So you have to make them the same base.
So I have to make them with the same base. So I can rewrite 16 as a base 4, right?
4 squared.
As 4 squared. Now remember, it's 4 squared to the x plus squared power. And what happens when I have a power to a power? What operation do I have to do?
Oh yeah, I know this. Multiply, I think.
Multiply. So I have 4 to the x equals 4. I'm not going to distribute it just yet because now I have the same base. Now I can just say x equals 2x plus 2. And then I'm going to go ahead and solve. So now I'm going to distribute, and that's 2x plus 4. So subtract x, subtract 4. I like to move the x over, just I don't want to deal with a negative x, so that's why I'm moving kind of everything over. But I could have left 2x, or regular x where it was, and I would get the same answer. But basically, I'm going to have x equals -4. So my final answer is
A.
A. This is still pretty easy, I think. But let me not get ahead of myself. All right, question number 2. The function f is given by f of x equals log base 2 of x. what input value in the domain of f yields an output value of 4. So remember that if I'm going to rewrite it so it's y equals log base 2 of x, if I am rewriting this as an exponent, I am saying 2 to what power equals x, right? That is I think the easiest way for you to figure it out. So what
It's C.
What?
Sorry. I was gonna say it's C. Because 2 to the power of 2.
Is that what we think?
Yes.
So we want it to be when the log 2 of x equals 4.
Oh, wait. No, never mind. I take it back.
So what is my answer?
Is it B?
It is B. So remember, once you put that, you can set the equal to 4 already. And then when you rewrite it, it's really saying 2 to the 4th power equals x. So 2 to the 4th
16.
16.
what?
16.
Yeah, oh. I was hearing, because you were saying 16, but all I could hear was the C sound. And I was like, no, that's not it. All right, the function k is given by k of theta equals 2 sine of theta. What are all values of theta for, so between 0 and 2 pi, where k of theta is equal to -1. So how do I do this problem?
It's
No.
kind of looking like a unit circle question.
This is a unit
Yeah.
circle question. So I'm going to go ahead and I'm going to say I need 2 sine of theta to equal -1, right? So if I solve for it, well, I have to divide by 2. So I'm looking for every point on my unit circle where sine is equal to -1/2. So first of all, I'm only looking for how many answers? 2, right? I know that because sine is only negative in quadrant 3 and quadrant 4. Those are the only 2 places where sine is negative, right? So then now I need to figure out what is my pi over what value that is going to equal -1/2 for sine, what is it?
D.
Yeah.
Okay,
Mhm.
I mean, yes, but
I mean, even you saying that it's only negative in quadrants 3 and 4, like I feel like it's easier to think of it that way.
Yeah. But the x
Oh, like,
value would be square root of 3 over 2, positive. Or it could also be negative.
Right, but it's just asking us for signs, so it would like
No,
either
yeah, I know.
way.
But she just asked for the x.
Oh yeah.
yeah, I was looking for the pi over 6 answer, and you guys were already like,
Oh,
right? So pi over 6 is my reference angle in unit 1. So I'm looking for something over 6. So automatically B is out, and so is C. Then now this part is where that quadrant 2, even if you don't remember the unit circle, right? As long as you remember that it's a pi over 6, or you just remember in the first quadrant, you can then figure out pi over 6 is in quadrant 1. That's going to give you a positive value because all your sine functions all your trig functions are positive in the first quadrant. So it can't be A when I'm looking for a negative answer. So my only answer that makes sense is D.
D.
Okay. Ooh, look. Which of the following expression is equivalent to log base 3 x to the 5th? This is easy. What do I do?
Um,
See,
expand.
What? Vale, you want to elaborate or not just say out?
No,
Yeah.
because I'm scared that I'm wrong. But I feel isn't it the same rules if we were to like do it the other way? We would just bring the number before the log to an exponent, so then we can just automatically assume that it's C. Or I'm just talking out of my ass. I might be wrong.
Right. So it's the product property of logs. No, power property of logs. Which the power property says if I have a 5 right here, it's the same as saying 5 log base 3 of x. So it is C. Does this make sense?
Yep.
Yeah.
If I'm going too fast, you guys can tell me. I'll slow down. Wait, where's Issa? Issa, here's a question for you. Concave up and down.
Oh my god, it is.
Which of the following statements is true about the exponential function h given by h of x is equal to -3 times 4 to the x? So first of all, I know that it's an exponential function, right? But now a negative exponential function, what happens with that?
I think it's negative because like the first number is -3. I think. Maybe. I hope.
Well, first, so, okay, hold on. So this is like the normal exponential function, right? We all agree with that?
Yes.
Yeah.
Yes.
So a -1 is going to go in this direction,
Right.
right? So now let me go ahead and look through my answer options and see which one makes the most sense.
So you can eliminate A and C.
So I can eliminate A and C because it says H is always increasing. Well, that's not true.
So then
And
it's
although it's
D.
concave down, it is not increasing. So H is always decreasing. So yes, yes, yes. And then it's either
D.
concave up or down, and it is D because it is always concave.
Genius.
Issa just needs 90% of this exam to be increasing.
90% of this and I pass. Flying colors.
All right, here we go. In the xy plane, the graph of a rational function f has a hole at x equals 2. Input values of sufficiently close to 2 correspond to output values arbitrarily close to 6. Which of the following could define f of x?
Okay, so it can't be C or D.
I agree with that.
So
'Cause-
why can't it be C or D?
Because it
'Cause
doesn't
it
have
doesn't
x
have a
minus
neg-
2 in both the numerator and denominator.
Right, so it doesn't have, I mean, the even if you don't understand the rest of what it's saying, it has a hole at x equals 2. That means you have to have x plus 2 or x minus 2 in both the numerator and the denominator. Otherwise, there's no hole at that point. Right? So now
Yeah.
I need to look at what it says. It says input values of f sufficiently close to 2 correspond to output values arbitrarily close to 6. So what that's saying is as you get close, so here's my x equals 2, why not? What they're saying is as you get close to this hole at 2, you are getting close, I'm a little off, whatever, to the point 2 comma 6. That's basically what it's telling you. So remember, like, when you have a hole, you solve for it, right? Because there's going to be a specific like y value, like this is where you would see the hole on your graph, right? So what you would need to do is figure out what's going to give you an answer close to 2, no, close to 6 as you get close to 2. So you would want to try with like 1.999 or something.
Miss Perdomo,
Yes.
This is
is
kinda-
that saying that there's an asymptote at 6? Like, will it never touch 6?
So it's not an asymptote at 6. It's when you would do, yeah, like your limit notation. So your limit as
Yeah.
x is approaching 2, your y values are approaching 6.
Is it
So
ever going to touch 6?
it's So a hole in a graph is not like an asymptote, right? Because the asymptote, you're approaching it, but you never cross it, but your graph will
Right.
continue. A hole, think of it more like a black hole. Like nothing
No,
is
yeah, but like I understand the hole at x equals 2. So is the part where it's like sufficiently close to 2 correspond to 6? Is that another hole or an asymptote?
So it's the hole. It's
Oh,
just
okay.
like a visual point on the graph
Okay.
where you see
Okay.
the hole.
Thank you.
So I need to figure out how close I can get to 6 using these values. Well, I would ignore my 2 here, and I would kind of then solve 6 x plus 3 over x minus 3. And then I would do the same thing with x plus 4 over x minus 1. Well, let's say I don't want to use 1.99. I think the one I think would work better, just because this is the no calculator section, is 2.001, right? So what is 2.001 plus 4?
Or
Six.
I mean 6.001.
Right. And then it's going to be over 2 minus, or 2.001 minus 1, which is going to be,
1.001.
so is that not getting very, very close to 6?
Yep.
It
Yes.
is.
So my final answer is B,
B.
right?
Also, I wanted to ask for letter A, does it matter that there's like a 6 in the beginning? Like, what does that like mean?
Did
Right.
they
So
just
the
put that
6,
there to confuse us?
yeah, I think that that's there so that when you look at it, you're like, and you read the problem, because
Arbitrarily
I
close to
think
6.
I think we can admit it's a very odd sounding phrase.
Yeah.
So I feel like they put the 6 there to be like, oh, there's a 6. The question mentions 6. It's got to be that.
Yeah.
So
Question.
yes,
I'm confusion. So, I understand like okay, like it's very close, like B is very close to 6, but then when we have A, aren't we are we I'm like
yes.
confusion on why it's not A.
So let's say I do 6 times 2.001 plus 3 divided by 2.001 minus 3. So what is 2.001 plus 3?
5.001.
Okay. And then 2 minus 3, or 2.001 minus 3 is going to be what?
Negative
Negative
1.001.
1.
So now this is not going to give me close to 6, right? This alone is going to be 30 if I ignore the decimals. And over 1 is not going to work out for me. So you see, Issa, like if I did exactly what I did, I just chose to do B first. If I did the same thing with A, I wouldn't get close to 6. Your goal is to get close to 6, but not necessarily reach 6. Or you could have probably just plugged in 2 and it would have worked out, but you get what I'm saying, Issa?
Yeah.
So that's why B is the one that works, because when you check with the values that are left over, you get close to that 6, which is where your hole is going to be drawn on the graph. Oh, these are fun. This is this is like, I think, like the most geometry kind of question you would get.
Ah,
Oh, it's not so bad. At time t equals 0, a water begins pouring into an empty container at a constant rate. The water pours into the container until it is full. The situation is modeled by the given graph, where time in seconds is the independent variable and the depth of water in the container in centimeters is the dependent variable. For which of the following containers would the graph be appropriate? So I have to look at the graph that I'm given and look at the containers that I have. Now, which ones can I eliminate really quickly?
Oh, I was talking D and A because A would be like linear.
Right. A would be very straightforward, very linear. It has no curve, nothing like that. This is going to have a curve. Now, D is like too curvy, right? So
Yeah.
not gonna work. Now I'm between C and B. So now I kind of have to look at my graph. I see. So as my time goes on, it's deep, then it gets a little bit slower, and then it goes back up to what it is. So what is the one that would work the best?
That
I
would
think
not.
C.
What are
C.
we saying?
C.
I would go with C.
Yeah, I think C.
I say B.
He says B. Anyone else with their guesses?
Because the thing about B is that it gets like wider at the top, so it would get like faster.
Because
I think
the graph it gets steep in the middle, so that means that more water is being poured in a small amount of time. So more water is gonna have to fit in the middle where it gets steeper on the graph, right?
Yeah, that's what I think. So
All right. So
Uh-oh.
Isa is right. It is B. The reason, the
okay,
reason
sir.
what you guys are confusing is that Y is the depth. So
Oh,
yes, the middle portion
Oh.
is the steepest, but that would mean that my depth needs to be much shorter, much
Wow.
smaller, right?
Oh
If
my God.
if I picked C, my depth would have to be much fatter. So the graph would look a little bit different. So B is the correct. So it's very important when doing these kinds of questions to make sure that you're reading what are your X and Y's. Because I feel like we're thinking like the amount of time to fill up the container, right? Or the amount of water. This is typically a question that would say like the amount of water going into the base is modeled by whatever. But this is not it. It's talking about the depth of the actual base, okay? So B is the correct answer for that one. All right, number 8. At time t equals 0, the population of a certain city was 23,144. During each of the next 10 years, the population decreased by 4% per year. Based on the information, which of the following models the population as a function of time t in years so between 0 and 10 years? Okay, so let me go ahead. City starting 23, 10 years decreased by 4%. And then I'm looking at the main thing. So,
Miss Perdomo.
yeah.
So since it says like a set value that it decreases by, it doesn't vary from that. So is it linear?
So,
I don't
population
think it's
growth.
C or D.
Population growth is one that I talked about as a very, very good model,
Yeah.
which kind of functions.
I think
I do not remember.
exponential.
It is for exponential.
But how is it exponential if it has a set rate?
So, because during the next 10 years, the population decreased 4% per year. So every year it decreased 4%, then 4%, 4%, 4%, 4%. So the 4% keeps growing exponentially.
Okay, but see, like if I saw that, I would be like, what? Because if that said like decreased by or increased by +2 every year, then wouldn't that be linear? Because it's like two more and then two more and then two more.
Right. So it would have to be like, it would have to say that it increases, something would have to tell you that that value is constant. The 4% decrease per year means that it goes 4 year, okay, 4, then the next year would be 8, then 12, then 16. See how it keeps growing? Because it doesn't say decreased exactly 4 over those 10 years or anything like that. It's saying that it's
Because
during
it's
the next,
about population, not percentage of decrease.
exactly. So yeah, so population is never going to grow in a linear function. There's too many different factors for it that it would never be considered a linear. Like if you have it as a linear, it's like a very specific data that is specific for a problem, right? But typically population is always an exponential growth or decay. So in this case, is it a growth or decay?
Decay.
Decay.
Decay. So we already eliminated the linear values. And then in order for a function to be decay, what does remember that it's y
Less than
equals
1, right?
exactly. So
So it's
b
C.
needs to be between 0 and 1.
0 and 1.
So
That's
the
perfect
value,
for answer C.
it is answer C.
Wait, explain that.
So exponential decay, right? Isa, I know it's decay because it says they decreased, and I know it's exponential because it's population growth.
Yes.
So then what I need to say is, okay, so B, for a decay function, my B value needs to be a decimal or a fraction, right? The other way you can think about it is because you have 100%, right? That's what every percent is out of 100%. And then they tell you that you have 4% decrease. So really it's a negative 4%. So you would subtract 0.4, or I should say it is 1.04, and you would get 0.96. So that's where the 0.96 comes from. And then it's versus the 1.04, which again, so this is for decay. For growth, your B needs to be greater than 1. Does that make sense, Isa?
Yeah. Yes.
Okay, I wanted to add something for clarity about like identifying whether it's like exponential or linear in regards to like specific like problems, or whatever, like the wording of it. I know
Okay.
because it's population that is exponential, but there are cases in where like, a population can be linear. But the thing with that, it's only linear if it were to say like 4% of its original population each year, because like that would be like a fixed number. So I mean, I don't know if that helps at all, but saying it decreases by 4% every year, we know that's exponential because the population is going to change every year. It's not a fixed number. But yeah, I was just saying because like there are cases, because I used to get confused on the same thing as
Right.
well.
So yeah, so that's what I was saying, that there are some specific cases where they'll say that it's a linear, but they would have to give the proper wording. So like Nico was saying, is if they had said something about 4% of the population, the starting population or something, it has to give more information for you to determine that it's going to be a linear function. This one is too like vague, and then they say it's just decreasing 4% each year, meaning you would have to go by the percentage of your previous year. So you would have to go by like, you know, 94% of the first year, and then that second year you would use 4% of that updated number, and then so on and so forth. So now this one, okay, so have we watched a trig identity video yet or no?
Not yet.
I don't know. I've watched up to 3.10, whatever that is.
I don't know. I don't even remember.
Me neither.
Okay. Let's see if we can do this quickly.
What is
Well,
SEC?
okay, so yes, okay. So SEC is
Isn't that
secant.
secant? Okay.
Yes. So that is a secant function. So this here is a special property that is secant squared of x minus 1. But there's an equivalent property that says that secant squared of x minus 1 is equal to the tangent squared of x. Okay, so I can rewrite this problem, and secant, by the way, is 1 over cosine of x. So I can rewrite this problem to say tangent squared of x over 1 over cosine squared of x. So far, so good?
Yes.
Now I can rewrite tangent as what?
Um,
Tangent is what?
Opposite over
Sine over
adjacent.
cosine.
Sine over cosine. So then I would have sine squared of x over cosine squared of x over 1 over cosine squared of x. Then,
Why do you have to rewrite it?
because I'm trying to simplify it, right? I'm trying to get it so that I can match one of these options that they give me.
Okay.
So now I can, well, I'm dividing fractions, right? So keep the same, keep the first term, change to multiplication, and flip the denominator. Yes?
Wait, isn't oh, never mind.
Now what
I
happened?
thought he was sine.
Right is sine.
You can eliminate
I
the
mean, like,
cosine squared of x.
Yeah.
Yes. Meaning that my final answer is
See,
Yeah.
See.
C. So this is the trig identities. Make sure you watch it.
Miss Perdomo.
Yes.
I was confusion in the second part. Like, why did you have to, like, I get why you got the sine squared of x and the cosine, but why do you have to put the, why do you have to put, like, why do you have to rewrite it?
Like, why do I go from here to here?
No, like, why couldn't, meh. Actually, never mind. I answered my own question.
Wait, so then are we not confusion?
Not confusion no more.
Okay.
Miss Perdomo?
Yes.
Sorry. So the secant squared of x minus 1, that entire thing is tangent squared of x.
Right. So the function says not the function, the property is tangent squared of x equals secant squared of x minus 1. And I think that's in, no. 3.12.
Okay,
So,
thank you.
I'm going to have the little list made up for you guys for tomorrow's meeting, or we can take some time at the end, but probably tomorrow because Pythagorean identities is going to be on that list of things you should have memorized. And I think it's better if you have watched the videos because then it's a little bit easier to see that it's not so bad because you can actually derive everything from that stuff. All right. The location of point X in polar coordinates is this. It's so cute, right? Is 1 comma 5 pi over 6, which of the following describes the location of point X in rectangular coordinates. So rectangular coordinates are the regular coordinates, while the polar ones are used when you have the polar graphs. In case you haven't seen it, this is a polar graph here. You see it's kind of like a unit circle, but with a bunch of concentric circles in the middle. It's not fun. So, but converting polar coordinates to rectangular coordinates, all I have to do is say, well, x is equal to r times the cosine of theta, or I'm sorry, it's going to be theta. I'm giving you the general one, and then r sine of theta, right? Because we know cosine is x and sine is y. So in this example, I have x equals 1 times the cosine of 5 pi over 6, and y is equal to 1 times the sine of 5 pi over 6. So this right off the bat, unit circle coordinates, right? Because it's a radius of 1. That means I'm in a unit circle. So what are the xy points for 5 pi over 6?
Negative 3/2, comma 1/2. So
Square root of 3.
yeah, sorry, A.
A. Yes?
Yes.
Once
I mean,
again,
wait,
what?
sorry. Is it going to be? Is it always going to be that formula in order to convert it?
Yes.
Like, okay, awesome.
Yeah, so like remember how I told you converting degrees to radians, you multiply by pi over 6 or pi over 180, right? Or 180 over pi if you're going from one to the other. And did someone get kicked out? And so it's the same thing. It is always going to be r times the cosine of theta, r times the sine of theta. It just so happened that this one was really easy because it was a unit circle, right? But yeah, that's as simple as it gets, converting them. It's more annoying to convert from rectangular to polar. But we are not doing that because we haven't gotten that question, and there is a YouTube video that you should watch first, and then you can ask me tomorrow. All right, the figure shows the graph of an exponential decay function of f. The coordinates of two of the points are labeled. If y equals f of x, what is the y coordinate of the point on the graph where x equals 0? So, what do I have to do?
I'm gonna be honest, I'm a little lost here. Cause like
Okay.
when you go to 0, it looks like it's going to infinity, right?
Yeah, it looks like an asymptote.
Well, when you are looking at x equals 0,
Wait, Loki crosses at one point.
yeah.
You're
Oh, I
so
was
right.
fully
Am I
looking at the
blind?
wrong side of the graph.
So let's kind of look at where my graph is going just based on the points. So 3, my y value is 5. At 2, my y value is 10. So what seems to be happening?
It's
By fives?
growing,
It's what?
growing.
But like how?
By fives.
Not by fives.
By ones.
Those are
Are we
both
talking about our x values or our y?
Yeah, what values
My
are we
y
talking about?
values.
multiplying by
It's
2.
growing
Yes,
exponentially.
Oh,
because
multiplying, yeah.
Oh, then it's
it is
A.
doubling, right? 5 times 2 is 10. So if we're kind of going off of that,
10
what would
times 2 is 21, and then for 0, 20 times 2 is 40.
Right. So if I was doing, so I'm at 2 here, so that means comma 1 is probably going to be somewhere around 1 comma 20. And then if I double that 20 again, I'd be at 0 comma 40. Easy?
Yeah.
All right, these questions
Yeah.
are
Yes.
still pretty easy. So it still concerns me a little bit. All right. The table gives values for a function g at selected values of x. Which of the following statements is true? So, notice they're telling me linear or quadratic, meaning I'm going
It's
to do
not
my
linear. You
what
do
is it?
the little subtraction thing. I forgot what it was.
Yes,
Differences.
successive differences. So from -3
Yeah.
to -2,
1.
1,
from -2 to 1,
3,
3.
1 to 6,
5,
6 to 10.
7, I think.
So
Yeah.
then those
2.
are not constant, but 1 to 3 is 2, 3
And
to
then
5
3 to
is
5 is 2, and then 5 to 7 is 2.
So immediately, not
It's
linear,
quadratic.
it's quadratic. So now I'm saying which one matches. So because the average rates of change over consecutive equal length input value intervals are constant, or because the successive second differences of the output values over equal interval values are constant. What is my answer?
D.
D.
I did successive differences, so that's definitely the one I should go with, right? This is also saying the average rates of change. I would have had to take the slope every single time. And as we know, on a quadratic function, the slopes are not constant throughout the whole thing, right? We've seen that
Yes.
from the curve.
Yeah.
So now another thing to mention, I mentioned it in the other videos that I've done before. This is the important thing to remember. Output values over equal length over equal interval input values. That is very, very important to remember because that's a very key thing that they look for in the FRQs. When you're given a sample like this, you have to make sure that you are telling them, hey, I checked my X values. They are evenly spaced. Remember, there was one example we did where my X values were not even intervals. Do you guys remember that? That was like a long time ago. And you had to basically skip one of the values in the middle in order to see the successive differences in the pattern. So you have to make sure that you say somewhere on the FRQ, if you have something like this, output values equal over equal interval input values. That is very, very important. All right, number 13. The function f is given by f of t equals e of t, and the function of g is given by g of t is equal to 7 ln of t. If the function h is given by h of t equals f of g of t, which are the following expressions for h of t when t is greater than 0. All right, so remember that this here is another way of saying f of g of x. I like that they have both different notations because it kind of makes sure that you know what you're looking at. So again, all I'm going to do is plug in g into f of t. So that's going to be e to the 7 ln of t. Now, before I do anything else, I want to rewrite it so that it's e ln of t to the 7th. So that's going to eliminate now my e and my ln, leaving me with just
T7, which is B. Yes.
which is the correct answer.
Yay.
All right. Here you go, Nico. The binomial theorem can be used to expand the polynomial function p, given by p of x is equal to x minus 3 to the 5th. What is the coefficient of the x cubed term in the expanded polynomial?
Oh,
So
geez.
we have a bunch of space for our beautiful triangle.
I think automatically it can't be B or D because it's squared, right?
Well, we gotta keep going. Let's go first. If you're gonna make that guess, Emily, we'll see. Wait, it was Emily. I don't have the chat.
Yeah,
box.
no, it was me. It was me.
Okay, I thought so. So I have what? 0, 1, 2, 3, 4, one more. All right, so here's my row that I'm looking at. And remember that when this is happening, this is x to the 5th. And then it would be negative 3 to the 0. Then I have x to the 4th, negative 3 to the 1, x cubed, negative 3 squared. Oh, this is the one I'm looking for, right? So it would be 10 times negative 3 squared x cubed. Well, they're only asking for the coefficient. So which option matches this?
B. You're joking. How come whenever I say it's not gonna be something, it ends up being that?
Emily, we already talked about this. Go against what you think it's going to be. Go with it. Go with the one you think is wrong. All right. So, wait, did we have any questions on that last one or we got it?
I think I'm good.
All right, look at this. The function g is given by g of x is equal to 2 cosine pi of x plus 1. So they're giving you a bunch of transformations to the cosine. Now, what can I eliminate right off the bat?
D.
D. Why?
Because of the way the graph starts, the cosine starts the opposite way on a graph.
Exactly. D is a sine function. I don't want that. Cosine functions all start at a maximum value. Okay. Now I'm going to go ahead and use my information of the transformations that I'm given. So the first thing is I'm a +1. So remember that my midline default is always at 0, right? And now a +1
would
says
bring
that
it up. So it's B, I think.
so now which graph lies in the middle of the midline?
Wait, it's A,
It is
right?
A. It is A, but B, as we can see, is not in the middle of the midline. So it is not B.
Is that just a rule that it has to be in the middle of the midline?
Yeah, that's what I mean, midline, middle line.
Okay.
So the midline has to be in the middle. Now I need to figure out my amplitude now says 2. So my amplitude, I have to go 2 down, 1, 2. But now I do this over here, and I'm also at 1, 2. So now I have A and C are basically the same kind of idea, except I can go ahead and figure out points, right? What is the cosine of pi? Well, pi, I know, because of my unit circle, is at -1, 0, right?
Yes.
So my cosine is always going to be -1. So if I had this all, and let's say x was equal to 1, that would be cosine, or I can just get rid of the cosine part. Okay, wait. Let me write out what I'm doing. So I'm now doing 2 cosine of pi, and x I'm going to make 1 plus 1, right? And like I said, this is going to just equal to pi, and cosine of pi is -1. So that's -2 plus 1, or -1. So I'm looking now for x. When x is 1, y is -1. So I'm now looking for the point 1 comma -1. Where is that
That's
on
A.
the graphs? It is in A. A is my correct function.
So I always
Yay.
get confused when I see like the 0 is less than or equal to x, which is less than or equal to 4. Like, what does that have to do with anything?
Right, so that's just basically telling you the little range you're looking at. Notice how on all my
Okay,
graphs I go
but
from
I'll
0
already
to
have it.
4. So like
Yeah, okay.
if I was testing this out, I have to use the numbers 0, 1, 2, 3, or 4.
Okay.
I can't go past that because that's not going to help me at all. So that's all it's saying. Okay. All right, this is probably going to be our last one. The figure shows the graph of a function g in the xy plane with 4 labeled points. It is known that a relative maximum of g occurs at A, and the only point of inflection of the graph of g is C. Of the following points, at which is the rate of change of g the least? Oh, this is an interesting question. So where would it be? So here's my, remember, like a rate of change, you can just imagine like the line, like touching it kind of against. And the more, kind of like the more difference there is, the greater the average
So
rate
it
of
would
change.
be A. No, it would not be A. No, yeah. Yeah, I think it's A.
Does anyone else have other guesses?
I mean, I don't
It's
understand
probably
how
not
that
A.
makes sense. Isn't it asking us the rate of the change? So wouldn't we need 2 points in order to determine like what it would be least at?
No.
It has it only 1 point.
So like I said, you're looking at this here, and you're basically saying, okay, here's one kind of a rate of change, if you had A and then another point around it, and then here's the one for B,
OMG, wait, no, I lied, it's C.
here's the one for C. Oh, that's why they're doing all these weird things. And here's the one for D. Right, so you're basically like trying to get a linear to touch it. You're basically making a tangent line to these points. So looking at all of these, which one would have the least change?
C.
What?
C.
What? How's it C?
Wait, don't tell me I was right before. Yeah, cause oh wait, no. Cause I'm thinking like which
Isn't
one has like
D
a straighter
literally on
line?
a line? D is on the line.
Wait,
How
the
is it
answer is
C?
C?
The answer is C because, so when you look at the graph, the point of inflection is like the steepest kind of point. It's the one where your graph is basically like right on, your line is right on top of the graph itself, meaning that the rate of change is not going to be very great, right? Remember, the more of a like D, the greater the value, right? It's going to have a greater rate of change. Now, the other thing is that the point of inflection always has a rate of change going from decreasing to increasing. So that kind of like cancels it out and kind of messes it up. So that's what makes it less.
So is it also because C has like the least amount of movement? Like everything else, something is changing?
Yeah, basically, yeah.
Okay.
So when you look at it, it has like your tangent line is basically on the graph.
Okay.
Question.
Yes.
But is if they tell us like the point of inflection, is the point of inflection always going to be the least?
Yeah, so the point of inflection is going to be the least because, like I said, it's like right there on the graph. It's changing from decreasing to increasing, so it's just a little bit off like all the time.
And how do we determine which one is the greatest one?
Well, you would see like D. You see how D has this big like separation from the graph? It's
Yeah.
going to have a larger rate of change. Because remember, the rate of change is the slope, so it's like the rise over the run. So you have to go up more and over more to match the tangent line of D to the actual graph. You get what I'm saying?
Yes.
Okay. So with that, I will let you guys enjoy the rest of your Saturday. I will most likely see you tomorrow, hopefully. Remember that tomorrow's will be around 7:45. If I'm running late, I will let you all know. And if anything, might be pushed to, I don't know, 7:50 or so. But I will keep you posted on that.